Do you have a question, David?
What are the balloons
for chemistry? Nothing that we are doing. Okay. As far as the moon goes, there's some things that I expect you to know about it. Number one, I expect you to know that the Earth has no atmosphere. Alright, let's focus on what we're supposed to be talking about. Okay, you should also know that the moon is smaller than Earth. So it has less gravity. Okay, now we didn't really talk about the implications of that, but you weigh less on the moon than you would here on Earth. Yes, Alyssa?
Why do we call it the moon instead of satellite?
It is a natural satellite. That's our name for it.
How do you call Earth?
I mean, the thing is, it's something that's been known from antiquity. Everybody that's ever looked up has seen the moon at some point, and so that was our first name for it. And that's really why we refer to other planets, things as moons, just because it's related to that first one that we figured out. Yes, Matea?
Do wolves actually howl?
Not really.
What's the classification of a natural satellite?
A moon is a natural satellite around a planet. Now, as far as, we're not going to dig too far into planets and stuff because we're going to talk about that in the next chapter. We'll look at what planets are and what dwarf planets are, the distinctions. Okay? All right, we should also know the theories behind the formation. We've talked about this before. How do most scientists think that the moon was formed? Casey?
Our old planet hit Earth when it was still kind of the big ball of molten lava.
Okay.
And then all these chunks blasted off of it, and in time they pulled together and made the moon.
All right, excellent. So we talked about that, right? A planet, and that planet we think was about the size of Mars, so smaller than the Earth. But a planet hit Earth. And it is important what Casey said, that the Earth was still, we'll say, soft. It was still kind of in that molten phase, so that when that hit, chunks came off, and those chunks coalesced into the moon. So you can kind of say that the moon was formed by the Earth blowing chunks. The Earth was tiny. That?
Well.
Yeah, I get it. I get it.
Daddy.
Oh. Yeah, that's where you need to stop, Justin. That is an okay metaphor,
You're so creative.
but we don't need to get that far into it. Okay. All right. As far as the moon's orbit,
It's free falling.
okay, yes, the moon is free falling around the Earth. That's true. But we want to talk about the specifics of it. How long does it take the Earth to go through one revolution around the Earth? No. Alyssa.
28 days.
About 28 days.
And then it's
28 days
It revolutionizes
for
and
one.
revolves 28 days.
Okay, 28 days for one revolution. Revolution means going all the way around the Earth.
And rotates.
But Alyssa is absolutely right. It is also 28 days for one rotation. Okay? Why is it special that those two things are the same? How does that affect how we see the moon? Other than Casey. Austin.
like, normally it stays on one side because we normally don't see it rotate, and it's not going straight at the equator, so then it's, if it was at the equator, it would literally to one side of it, but now it's
Okay. I think you're sort of on the right track. Get a little wordy there. I heard Alyssa throw out something that was maybe a little more succinct. What did you say, Alyssa?
we only see the one side of the moon.
We always see one side of the moon. Yeah, I know you did, Austin. Okay, so because of this, we always see one side of the moon. Okay? Okay, what's it called? Okay, this is called, right, tidal locking. So tidal locking is the process where the revolutions and the rotations are equal. Okay? And we will see when we study other planets that a lot of other planets have moons that are tidally locked to them. Okay?
I was too.
Now, here's one other thing I want you to know, though. What do we call the side of the moon that we see all the time?
Near side.
The near side.
Just yes.
What would we call the side of the moon that we don't see?
Far side.
Far side, not the dark side.
I know, but
So listen,
that's way better.
now this is something, I know the dark side sounds cooler, but this is something you need to know. Remember, the moon is like the Earth in the fact that there's always one side dark and always one side light, but it does change. Right? During a full moon, we see that the near side is all lit up. During a new moon, the far side would all be lit up. So there's no, like, one part of the moon that's always in darkness. I want to make sure that you guys understand that. So we have near side, and then the other one would be the far side. Okay? So, talked about all that. We should know also about the moon. Let's throw this in here. Some of the formations. Okay, so what are some of the formations that we can see on the moon? Austin? Maria. It does look like Maria, but remember it's after the word Mar, which is lake. Okay, so what would a Maria look like? David?
It's like an ocean. Flat, black.
Flat and black, okay? Okay, good. What else? Alyssa?
Highlands, bays, craters, all those.
Okay, let's go one at a time. Highlands. How would we describe highlands? What are they basically? Mountains, okay? Now they're not formed the same as mountains are here on Earth because there's no tectonic activity, but we can definitely call them mountains. How do those mountains compare to the ones here on Earth? Alex? They are taller. Why are they able to be taller? Trace?
Because there's no tectonic plates and stuff, and they're solid, so they don't sink down.
Okay.
They don't weigh.
Right, they don't sink down, and they also don't weigh as much. And what's one other reason? David? There's no erosion. Okay, so the highlands, the mountains are very tall. And as Trace pointed out, they don't sink because there's no molten core to the moon. They also weigh less because there's less gravity, and there's also no erosion.
But wouldn't there be like a little bit like there fits in?
Yeah, definitely. I mean, if a
Like
meteorite
collision.
hits it or something, like some sort of collision like that can break it off, but generally that's not going to break off huge parts of a mountain, right? Just so at most to take one little peak off. Okay, Justin.
What if you like took off the rest of the decided I'm going to take off all of this.
I did it.
So you have a ginormous mountain.
But
It's just a
it's
giant.
not solid all the way through, right?
Yeah.
So we got to start at someplace. We started at sea level. Above the common level, these mountains are up. I see what you're saying. That would be kind of a relative thing. Yes, it would be bad. Okay. We don't have a lot of time to get through all this review stuff. We also have craters. And as we talked about, craters are caused by impacts. Okay. Now the Earth, and I maybe didn't explain this very well, so I want to go over it again. The Earth, in its early history, had to have gotten hit with just as many meteorites as the Moon. So the Earth should look just as cratery. Why doesn't it?
But it's filled in
Erosion.
water, right?
Yeah. What else? Yeah.
Filled in with lava.
Okay. Tectonic activity. So the Earth's surface changes all the time. The Moon's doesn't. We talked about how those footprints from the astronauts are going to be there for thousands of years because there's nothing to change it. On the Earth, it get changed pretty quick. Thank you, Justin. Okay. So craters come from impacts, and then we have rays. What is the ray actually? Some other people answer it. Like Dennis. Any idea what a ray is?
A ray is a light of a sun that hits us and we only see light.
Okay, that's true, but we're talking about it in the context of surface features on the Moon.
Oh, on the moon, it's a ray that comes from the sun to the moon.
No.
Way to double down. Sorry, no. Okay. Kylie,
What?
any idea what a ray is on the Moon?
Where it flashes a shadow on the sun.
Not quite. Jacob, how about you?
Okay. It's where something impacts the moon, stuff from the impact settle down.
All right, so after a crater is formed, the stuff that gets blasted out has to settle down, and it's going to form these rays that come. Okay, so this is the settling
Dust.
we'll say of material.
Of regular.
Yeah, regolith, dust, and rock and all that kind of stuff. Settling of material from impacts. Okay, and Casey does bring up an important term here. We maybe should have put farther up, but we'll put it right here. Remember, we call the material on the Moon regolith. That is a good term to know.
That's the material on the moon.
Yeah, all the rock and dust and stuff that's on the Moon is the regolith. Okay. Moon phases. What causes the moon phases? Alyssa.
Positioning of the moon around the Earth, and then the sun hits it, and it's only just visible in a circle.
Okay, so that's a pretty good explanation. I'm not gonna dumb it down. I'm going to reorganize it just a little bit here. Let's say that the moon phases are caused by the light. Actually, sorry. Let's say sunlight. We can see based on the moon's position. So it's basically just the portion of the moon that half of the moon's always lit up, but sometimes we can't see the entire half. If we can't see any of the half that's lit up, sometimes we can only see part. Okay? Now, I will tell you, on the test tomorrow, you are going to need to know the difference between waxing and waning. Okay, Kylie?
Weakness actually is more. Yeah.
Well, and more and less, okay, I think it'd be better to frame it more as growing lightness and shrinking. Okay, that's true. So what? To wane means to fade. Okay, so the word itself, the term itself, means to fade. So I guess that's more to talk about the shrinking. So waning is the portion where it's getting darker and darker. Waxing is the when it's going from darker to lighter. Growing lightness. I will tell you, on the test tomorrow, there will be some questions, at least one anyway, where I show you a moon phase, and you have to tell me what moon phase that is. You have to tell me whether it's waxing or waning, and you have to tell me whether it's a first quarter or a gibbous or a crescent. Okay?
We will learn, like, put all this down, like, crescents and stuff like that.
Get as much time as we can. We don't have a whole lot of time. I mean, Matei, you missed a whole lot of time. You will have some catching up to do. You'll have to look at the book. That's part of what the homework assignments will help you with. Okay? How can, when looking at the moon, let's say we had gibbous moons, right? What does gibbous mean?
Over half.
Over half. Okay? So this would be a diagram of a gibbous moon, right? Over half of it's full. This also, though, would be a diagram of a gibbous moon. You have to be able to tell me which one's waxing gibbous and which one is waning gibbous. Justin?
Waning.
How would you know?
Because it's scientific.
No.
Because the moon rotates this way.
Okay? I mean, I don't know how the best way for you guys to remember it. I don't have a trick to it, but I always remember that waxing is on the light part is on the right. Okay, the waning would be on the left. So this one would be waxing. This one would be waning. I think waning only has one N. Keep doing that.
Oh, jeez. It does. That was probably warning.
Okay, and that's going to be the same whether we're talking about gibbous or crescent. If you see the light side is on the right, that would be waxing, whether it's we're talking about crescent or whatever. Okay. Waxing, the light side is always on the right, whether it's crescent or gibbous or whatever. Okay? Also, on the test tomorrow, I should be able to show you the position of the Earth, the Sun, and the Moon. This will be the Earth, and let's say this is the Moon right here.
You would not be able to draw how far apart they are.
We're looking just on relative position here. So, based on this, the position of the moon, where it is compared to the Earth and the Sun, you should be able to, now I'm not going to worry about whether it's waxing or waning as far as this goes here, because that might be a little bit hard for you to look at. But you should be able to tell me whether this is going to be full, new, first, a quarter, a gibbous, or a crescent. So which one would it be? If that's not right, crescents. How do we know? Melissa?
It has the shape of a crescent.
How can we tell from the diagram that it's going to be a crescent, though? Casey?
Oh, because what is it?
If the sun is here, the earth is here, and the moon is here, then you're only going to see this part of it, and the reflecting light from the earth.
Okay, I mean, some of you might be able to see that in your head, right? But we might need a little bit better way of figuring that out. Here's the way I always think about it. Here's the sun, right? If we kind of draw a line through the Earth like this, okay, that I would say is perpendicular to the way the sun's light is shining. The sun's going to be shining this way. You guys know what perpendicular means, right?
Yeah.
Okay. Then the perpendicular line, this would be where the quarters would be. So if it's right on that perpendicular line, those would be quarter. Okay? Half of the moon is lit up. If it's right here, would that be new or full? New, right? The sun is shining on this side. It's going to be this side of the sun that is lit up. We're going to see the shadow side of the sun. So this would be new. That means full would have to be over here, right?
So it makes like a
Okay.
square.
Right? So if it's anywhere in here, it would have to be crescent because this is going from quarter, which is half of the moon, towards darkness or back. If it's on this side over here between the quarter and full, then it would have to be the gibbous ones where most of the moon is lit up. Okay, so if you can remember the positions of new and full and where the quarters are, then you should be able to figure out whether you're talking about crescent or whatever. And again, on this, I'm not going to worry about whether it's waxing or waning. You will have to tell me waxing or waning if I give you a diagram like this. But as far as this goes, I just want you to be able to tell me whether it's new, full, quarter, or crescent or waning or gibbous. Yes? Awesome.
Never mind, never mind.
Okay.
I was looking at the other guy that
Okay. Okay. Other things we talked about, eclipses. Let's talk about solar eclipses first. Which one of these, if I number these, let's say 1, 2, 3, 4, 5, the ones that I've got drawn up there, in which one of those would we, positions, would we see a solar eclipse? Give me the number. Trace, what do you think?
That's it.
Nope, sorry. Would you like a second try?
New moon. The new moon.
The new moon, position number 1. Because remember, what is a solar eclipse?
The shadow of the shadow.
Okay, but the moon has to go in between, for us to see the moon's shadow, the moon would have to go in between the sun and the earth. Let's write that down. Solar eclipse. Sun, moon, earth. The moon has to be in between, and because of that, this is only going to happen at new moon. And it would probably be good to put down, as I said before, what we're seeing is the moon's shadow falling on Earth. Okay? Yes, Jacob.
Okay, so is there like ever a time that we only see like the bottom part of like the moon? The sides?
The bottom or the top or the side?
Yeah, like instead of like part of the one side. Or the top. See like the bottom.
No, because and that's kind of how we orient top and bottom. Is just orientation to the sun. Right? That's what you're saying. Okay. Now, solar eclipses, right? There's a few other terms that we have to throw in here that deal with solar eclipses. One is the difference between total and partial.
Annual.
We'll talk about annual in a minute. Okay? And a total solar eclipse would fall into a region of the moon's shadow that has a specific term. What would it be? Casey?
Umbra.
The umbra. And remember, the umbra is the darkest part of the shadow.
It's like an umbrella.
like we said before, I think umbra means to cover.
Does that say darkest?
Darkest. Darkest part of the shadow. Okay, so what would we call the part where there's only a partial eclipse? Close. Not preumbra, penumbra. Penumbra. Okay, and if you're in the penumbra, you can still see, well, you're only seeing part of the shadow. Okay, then we've got another term called an annular eclipse. So what would be the difference? How would we describe an annual?
It only happens so much.
Nope. Austin?
Annual is like, so it's like when the moon is not totally over the sun. It partially covers the sun.
Okay, so what we would say in an annular eclipse is that the moon can't, it's not just like a partial eclipse, it's that the moon can't even cover the sun completely. Why? Why would it be that the moon wouldn't be able to completely cover the sun? Alex? Okay, it's at its farthest away point, it's a little bit too far away to completely cover the sun. So we'd say it's too far away. Okay, and then I think the last thing that we need to talk about, well, we got to talk about tides too, but lunar eclipses and then tides, and we'll be done.
We only have 5 of those.
I understand that. We need to do it fast then.
Yeah.
Lunar eclipse. Okay. Lunar eclipses happen, and I'm going to stop taking questions so we can get through this faster. Lunar eclipses happen when the order is Sun, Earth, Moon. And this is where the moon is in Earth's shadow. Do you really not see the moon?
No, it's red.
Why does it get red and not just disappear?
Like,
Okay. Right, I said I was going to stop taking questions because we are running out of time. So remember that the light gets bent through the atmosphere, and only the red light actually makes it to the moon. So light bends through Earth's atmosphere, and only red makes it to the moon. Remember, both lunar and solar eclipses happen infrequently because the moon's orbit is tilted, and so you're not going to see those very often.
Turn into a larger area.
Yes, you are correct about that. Lunar eclipses are seen pretty much anywhere. All right, let's focus here, guys. So we still have to talk about tides. Okay? So remember, tides are caused by the moon pulling on the close side of the Earth and making it bulge. And that bulge, remember, really only affects ocean water. Right? So the moon pulling on the Earth makes it bulge a little bit, that creates high tides in line with the moon's pull. And so what happens is the Earth rotates through these bulges, and we end up with areas getting too high and too low tides per day, roughly. It's not exactly a 24-hour period.
24.
That's because the moon is moving as the Earth is rotating around. Okay? Now, here's the thing, though. You are going to need to know the difference between spring and neap tides. Okay? In a spring tide, the sun pulls along with the moon, and you get more extremes. High tides are higher, low tides are lower. In neap tides, the sun pulls perpendicular to the moon, and so the tides are less extreme. Okay? Now, what would be the cycle of spring and neap tides? I mean, how often would they happen?
No.
Every year.
No.
Every month.
Not quite month,
28 days.
but you would get 2 of them every 28 days because of the way that the moon goes around. Okay? So you get 2 spring and 2 neap every 28 days. Because it depends on how the moon lines up with the sun. As the moon, if the sun is Justin, as the moon's over here, you get a spring. As it comes over to here, you would get a neap. Over to here, another spring. Over to here, a neap. Back around to its original position. That takes 28 days because we know it takes 28 days for the sun to. All right. Study for your test tomorrow.
I always do.